this paper will be having 75 marks. But in this particular video, what I've just done is that I've tried to pull together about 20 questions which are touching in various topics that will be tested. Now we are going to cover topics like discriminant, binomial expansion. We'll cover that, transformation of functions. We look at radian measure, trigonometry, sequence and series, circle geometry. We shall look at it also improper integrals. We shall look at rate of connectedness, and also we shall look at differentiation and integration, which also will be involving converting a gradient function to get a curve, with how to find the gradient, how to find the turning point, stationary point. All those we are going to have a detailed discussions on how you are supposed to handle such kind of questions. So don't skip any part of this video so that you can be able to get the best of it. So let us now dive in, look at the first topic that we're going to look at. And the first topic actually here is coming from discriminant, and I believe you've done that such kind of a topic before. You are told, you may be able to be given a question that looks like this, whereby you are told that express 4x squared minus 24x plus p in the form a into x plus b squared plus c, where a and b are integers, and c, where a, b and c are integers, and c is to be given in terms of the constant p. So the first thing that we need to do here, I'll need to write this equation the way it was, and I will start by writing the equation the way it was, and I will group the first two so that I can be able to factor 4 out. Now once I've factored 4 out, you can see now I'll be having 4 into x squared minus 4x, 4 into x squared minus 6x plus p. And at this particular point now you can see I'm going to complete the square inside the bracket, and I'll take a half of the number 6 that we have there. Then I'll subtract this 3, I'll subtract it out and square it. Anytime you are doing completing the square, remember if you expand x minus 3, you are going to get positive 9 at the end, and yet it wasn't inside that bracket where we are having x squared minus 6x. So this means you have to subtract that so that you can be able to retain the information the way it was. So if we try to open the bracket, in this case we'll be having 9, 4 is going to affect these two terms, and then we're going to have negative 36 plus p. I'll be happy by writing 4 into x minus 3x squared, and then I'll say p minus 36. So this is the form that was expected, so that you can be able to get a whooping 4 marks in your P1 paper tomorrow. So if you're going to do that exam, let me also take this opportunity so that I can be able to wish you good luck, and I wish you the best. Now moving to the next part, that is part B. In part B, you are told hence otherwise find the set of values for p for which 4x squared minus 24x plus p equals to 0 has no roots. Remember, when you are told that a quadratic has no root, it means the discriminant is actually less than 0. So you need to remember that when you are given a question and you are told it has no root, it means the discriminant is less than 0. But if you are told that it has 2 distinct roots, it means you are going to say the discriminant is greater than 0. But if you are told it has 1 repeated root, at that given point you are going to say the discriminant is going to be equal to 0. But on this particular question, we are going to equate the discriminant equal to 0 in order to earn our marks. All right, now the formula for finding discriminant is given there. D equals to b squared minus 4ac, and then we can be able to identify what is our a and what's our b and what's our c in this particular part. This is our a, this part is our b, and this part is our c. So you see now we have substituted, and upon substitution, this is what we are able to get. So if I take 576 on the other side, you can see now I'm having my answer being P is greater than 36. Now, something that you need to remember is that when you divide both sides by a negative number, you are going to change the sign of the inequality. All right. Moving to question number 2. This is a question that we are going to look on the concept to do with binomial expansion. Under binomial expansion, you are going to do a situation whereby you are going to use combination, whereby you have 2 plus 3x. So this kind of binomial expansion, you need to use combination. But if you are having 1 plus x, you are going to use the binomial theorem, whereby you're going to use factorials. So we're going to see that in the next part of the question. So looking into this, so we're going to start by saying that this can be written as 2 raised to power 4. The power 4 is given there. So the first term, which is 2, is going to be raised to the power that is given. And then the powers of 2 are going to decrease. As the powers of 3x are going to be increasing. So we're going to have 4 combination 1, 2 raised to power 3, then 3 raised to power 1. Then we're going to say plus 4 combination 2, 2 raised to power 2, and then we have 3x raised to power 2. So since we are finding the first 3 terms, we need to stop here so that we can be able to simplify whatever we have here. So we can be able to put this in a calculator. 2 raised to power 4 is 16. For combination 1, if I put this in my calculator, I'm getting my answer being, then I need also to multiply by this 8, and 4 combination 2 is 6 times 4, then times 9 raised to power 2. So this is going to simplify to 16 plus 96, then plus 216 x squared. So this is the first part of the equation. And since you are supposed to find the coefficient of x squared in the expansion here, but you see we have already expanded 2 plus 3x raised to power 4. But we are having 1 minus 2x raised to power 5, which has not been expanded. So meaning we are going to first work out this particular part so that we know what is the expansion of this. And this is the part now I told you you are going to use. This is the part you are going to use factorials. Yeah, this is now the binomial theorem. See here. So which means that if you're having 1 plus x raised to power n equals for you to expand this, we're going to say is 1 plus the first term will be 1, then the second term will be n. N is the power times the value of x, the x part, and then the third term is going to be n into n minus 1 over 2 factorial times x squared, right? And the next term will be n into n minus 1 into n minus 2 over 3 factorial times x raised to power 3. So this is how you use this particular formula. Now let's see how can you use that formula in order to expand 1 minus 2x raised to power 5. In order to do this, we are going to identify what our x is. Our x is actually negative 2x. So this is the part we're going to substitute where we have this x here, and then our n is actually power 5. Then now if we start substituting into our formula there, this is going to reduce to that, and then we need also to have let's just stop there, because we are going to be having the coefficient of x squared. This is enough because already we have negative 2, that is x raised to power 2. So if it's going to be multiplied by the first expansion that we had obtained, we can be able to get x squared. So if we simplify this, we're going to get 1 minus 10x, then plus 40 plus 40. Yeah, this is going to translate to Actually 40. Yeah, right. Let me confirm using a calculator. Yeah, this becomes 40x squared. Now, because we're expanding this, we are going to multiply the two expansions together. So we are going to write the expression the way they were first, so that we can be able to multiply the two. Right. Let me just copy them so that we can be able to do the expansion of the two. So we shall copy the first part. Yeah, this was actually this. And then multiply to the second part that we obtained, plus 40x squared, like that. All right. So once we have this, we are going to multiply the terms that are going to give us a coefficient, the terms that are going to give us x squared. So let us see, we are going to get x squared. So this term here and this will give us x squared. So this is going to be 216 x squared terms that will give us coefficient of x squared. So we're going to say this part is going to be 216x squared plus this 96x multiplied to 10x is going to give us x squared. So we're going to take that, and that's going to be a negative number, right? And 16 times this one is going to give us x squared. So we are going to take this number as well now, but this is going to be a positive value. And then now, if we try to work this out, we're going to get our answer as such. Then now, since it's negative 104 x squared, which means we are going to pick the number in front of x squared, which is the coefficient that we were being asked. Right. So that's what you are supposed to do. So this question is helping you to remember how to use those two formulas. And because tomorrow you must be tested on binomial expansion, there must be a question on that. Moving into functions, and here you are told that f of x equals to x squared minus 4x plus 3, where x is greater than c. G of x equals to 1 over x plus 1, where x is greater than negative 1. Then we are supposed to express f of x in the form x minus a squared plus b. Now, this one, we have already done a question similar to this. So this is just a walk in the park. You are going to group these two factor, then divide by 2 in order to get 2, and then complete the square like that. Already remember, we had said from the previous question that this number that is inside the square, this is x minus 2, this 2 that is inside where we have squared, you have to subtract the square of that number outside, because if you square this part x minus 2, you are going to get positive 4. So to cancel that effect, we must, it's a must that you have to subtract. Even if the number was a positive or a negative, at that point, you must subtract. So simplifying this, we're going to get f of x equals to x minus 2 squared, and this is going to translate to negative 1 at that given point. So we have a function, and it's given that f is a one-to-one function. So we are supposed to state the smallest possible value of c. Now, using this function that we have completed above, we can be able to get the turning point. The turning point, or the minimum point of this graph, or of this curve. So once we identify the turning point, we can now be able to state what is the least possible value of c. All right. So let's continue. All right. So what I'm going to do at this given point, from the function that we had completed above, I'm going to pick the minimum point. And remember, for you to pick the minimum point, you only look at inside the bracket, you pick the opposite sign, and the number outside you pick it the way it is. So that is the turning point. So if you are going to be given questions whereby you are expected to state the turning point, the maximum point or the minimum point of a function, and you have completed like that, you need to pick one number that is representing the x. Okay, now since we are told that x must be greater than -1, so the minimum point is going to be c, which is going to be x is greater than 2. So our minimum value of c is actually going to be equal to 2. Now we move to the next bit of the question. Here we are told that given that c equals to 5, so the domain of f of x is going to be what? Going to be x is greater than 5. So which means in order to get the range for f of x, we are going to substitute whatever that we are given as the value of x in order to get the range for f of x. Now this is the 5 that we are being told. So can we be able to get what the range of f of x is? So f of x equals to x minus 2, and then this is actually squared minus 1. So for us to get the range for f of x at that particular domain of x is greater than 5, when we substitute that, we are going to get the value equal to 8. So our range for the function is actually 8. And that will mean that if the range of this function is 8, then when you find the inverse of the function, the range becomes the domain of the inverse function. So you can now say range of f of x becomes, of course, the domain of the inverse function. Therefore, the domain of the inverse function is going to be 8. So the next part that we want to do here is to work out the inverse of the function f of x. So first we were given this, and we have already completed the square. So you are going to change f of x to y, and next you are going to switch the values of x and y, and then you try as much as possible to make y the subject of the formula, and then you can now see we are going to have our inverse function, and then we're going to decide which one is going to be the correct sign here, because we were told that c equals to 5, so the domain is x is greater than 5, so meaning that we are going to substitute into this particular part, and it will mean that the sign we're going to use is a positive sign, so that we have a positive value. Find an expression for g f of x and state the range. Find an expression for g f of x and state the range. So anywhere we have x in the function g, we are going to substitute x squared minus 4x plus 3, which is going to be all right. So if we open the bracket and put the like terms together, we're going to have x squared minus 4x, then plus 4, which is going to factorize. Of course, we can be able to factorize the denominator so that we can be able to express it as a difference of two squares. Is going to be like that. So given this function here, we can be able to graph and show how that graph looks like. This graph is a positive kind of graph, meaning it cannot go below 0. Yeah. So because we were supposed to set the range of f of x, but remember we were given the value of x being value of c being equal to 5. So if you substitute 5 here, we are going to get the corresponding value of y. So which means that the range of f of x is going to be within 0 and 1 over 9. So this is going to be the domain of f of x. We are going to substitute 5 into that. So if we substitute the domain of f of x, we are able to get the range of f of x. Domain of f of x we were given as 5. Then if we substitute it into gf of x, you are going to get the range of gf of x. So the range in that case, if you substitute, you are going to get 0. This is actually, let me see here. So the range of gf of x is going to be what? If we substitute here, we are going to have from 0 all the way to 1 over 9. Yes. Because if you can look at this function as the value of x increases to the right from 5, the graph keep on decreasing as it's approaching 0. But this graph is never going to touch the x-axis. So that's why we're saying the range of gf of x is going to be greater than 0 and less than 1 over 9. Moving to the next question, we are told that the equation of a curve is y equals to 2x squared plus kx plus k minus 1, where k is a constant. Given that line y equals to 2x plus 3 is a tangent to the curve, find the value of k. Find the value of k. So from this equation that we are told that y equals to that, we need to equate these two equations, equating the two equations so that we can be able to find the discriminant. And in this case, if you equate the equation, put the like terms together, and since the line is a tangent to the curve, it means that the discriminant is going to be equal to 0. Yeah. So since it's touching at one exact point, we are going to have to have one repeated root. Yeah. So this is because this curve is going to touch the tangent is going to touch the curve at specifically one particular point. So going as per that, we are going to say the discriminant therefore is going to be equal to 0. So if you are going to be given a question to do with a curve intersecting with another line, if it's a tangent, you are going to take the discriminant 0. But if they are meeting at two distinct points, we are going to say greater than 0. But if they are not touching, there is no solution, the discriminant is going to be less than 0. So now looking into this, let me just move a little bit so that I can have enough space to write. I can be able to write the formula for discriminant is that substituting what I have so that I can be able to simplify. I'm going to be having k squared minus 4k plus 4, and that is going to be 8 into k minus 4. Then now putting the like terms together, can see we are going to have k squared minus 12k plus 36 equals to 0. Solving this, we are going to get what? We are going to get the value of k to be equal to 6. Only one value. The value of k is 6. Now, given that k equals to 2, express the equation in the form. Surely, these questions, we have done this kind of question enough, so I don't believe we are going really to dwell much explaining this one. So you are going to factor out what's common and then try to complete the square inside the bracket, right? Then remember to subtract the square of a half, and then we shall say plus 1. Simplifying, we end up having this kind of an equation, and from here we are supposed to state the coordinates of the vertex of the curve. Coordinates are gotten from that completed part, so you are going to pick a half. You are going to pick negative a half, because inside the bracket we have a positive, so you are going to pick negative, but outside we have positive a half. You are going to take it the way it is, like that. All right, now moving to radian measure, and here one of the important formula that you must know is the formula of finding arc length, and arc length in terms of radians. So this is going to be theta r. Area of a sector is going to be a half theta r squared. So once you know that, we can now be able to go straight into the question and get to see what we were expected to do at this given point. The diagram shows a sector CAB, which is part of a circle with the center C, and the circle which is center O, we are told that the radius R lies within the sector and touches it at D, E, and F, where COD is the straight line and angle ACD is theta radians. Now we are supposed to find CD in terms of R and sine theta. CD, you can see from C to D, we are having the length CO, then OD. But for us to find CD, first we need to find CO using the triangle that we have at that given particular point. So using triangle OFC, this is a right angle triangle. We are going to use it to find the length of OC. But we can now say that sine theta equals to opposite over hypotenuse. So our opposite is R and our hypotenuse is actually OC. Now we can make OC the subject of the formula and have our OC to be sine R over sine theta. But CD is actually OC plus the radius of that circle. So we are going to, let me just move this down here so that we can be able to have it there. And then now I can be able to say that CD is OC plus R because of that radius there. And if I can be able to add that, I'm going to say I can write it in the form of this, or I can also express it in this other form like that. All right, so this is how to find the arc length, rather the distance of CD. Now we need to find the perimeter of a sector. You are going to be tested on how to find perimeter of a sector. Remember, you need to know how to find arc length, and the perimeter is actually distance or round. Okay, in order to find the perimeter, we are going to use this formula, and we shall find now we are going to find the arc length, and this is going to be, remember, CD is equals to that, yeah. Now substituting the value R equals to 4 And the angle now here, we're going to use 1 over 6 pi times 2. Yes, times, okay. Arc length equals to the radius times the angle in radians. So the radius now, in that case, is going to be what? Let's just go back to the diagram and get to see what we have there. Okay, we're supposed to find the perimeter of CAB, the perimeter of CAB. So first, for us to find the perimeter of CAB, we need to find the arc length ADB. The arc length ADB is going to be given by theta r, or r theta. The radius is the distance CD, the one that we had obtained, and the angle that we're going to use is also given down there. So we are going to say this is going to be arc length, is going to be equal arc length of this arc length. We're going to say that's going to be equivalent to r theta, and that's theta also we are given, but our radius is that length. So CD was given as r plus, we have shown this, that CD equals to r plus r over sine theta, but now we are told r equals to 4, so we can be able to substitute 4 in this part so that we can be able to use it as a radius at this given point, right? Then we are going now to multiply this radius by the angle, and the angle is going to be 1 over 6 times 2, 1 over 6 pi times 2, which is going to be 1 over 3 pi. All right, if you simplify this, we're going to get our answer as 4 pi as the arc length. But remember, if you are finding perimeter, perimeter is distance or round, so we are going to add 12 plus 12 plus 4 pi, which is going to translate to 24 plus 4 pi. Next part, we are supposed to find the area of the shaded part. Now, in order to find the area of the shaded part, I'm going to consider the triangle OFC. Then I'll use that triangle. I work out the area of that triangle, right angle triangle there, OFC. Then I will subtract the area of the sector where we have the center O, right? So this sector of the circle, part of the circle, so meaning we need to find what the angle that we are having at F or C. But since we know what the angle theta is, we can be able to find the angle F or C, which will be used in the process of working out this question. So let us go and extrapolate that so that we can be able to show what was expected to do in this part. Let me draw that triangle there. So if I draw this triangle, I'll have 90 there, and then I'll have my radius 4 at that given point. So I can be able to find the height of this triangle, because I'm going to use a half base times height. So I can be able to use the angle and the opposite side, which is 4, in order to find the height of this triangle, so which I can call x. So our x is going to be actually 4 over 10, 1 over 6 pi. So if you work out this, you are going to get your answer as 4 root 3. And because we are supposed to give the area of the shaded part in terms of pi and root 3, so I can be able to draw that sector there. So we are finding the shaded area of the upper part. But now I need to find the unshaded part of the sector here, but of which I need to find the area of the triangle first. So the area of the triangle is going to be a half base times height. And the height value of x, we had gotten it to be 4 root 3 times 4. And working out that, we're going to get 8 root 3. Next, we need to know what is this angle down here. And of course, that angle is actually a third. So I can be able to find the area of that sector. Yeah, so if we multiply, we are going to get what? Our final answer becomes, let me just use my calculator and check, 8 over 3 pi. Now, in order to get the area of the shaded part, we are going to subtract the 2. Once you have subtracted the 2, then we shall multiply the 2 in order to get, because we had originally the shaded area that we are working out, we are having two right angled triangle, that is triangle FOC and triangle OEC. So meaning, if I've gotten the shaded area of one of the triangle, to get the area of the other one, I need to multiply by 2. Okay, so this is the area of the part that we have worked out. So what I did, I found the area of the sector minus the area of the right angled triangle in order to work it out. And if you are new to Proflan YouTube channel, consider subscribing so that anytime we're going to upload new tutorials, you'll be notified. All right, moving to the next part. I worked out the area of the triangle, then I worked out the area of the yellow part, the one that I've dotted yellow, then subtracted that area from the area of the right angle triangle, then times 2 will give us the area of the green shaded part, the original part that was shaded here, this part there. Okay, and that's what we are supposed to do. In question number 6, over a 21 period of athletic over a 21-day period, an athlete prepares for a marathon by increasing the distance she runs each day by 1.2 kilometers. On the first day, she runs 13 kilometers. Find the distance she runs on the last day of the 21-day period. This is actually arithmetic series, and 2.1 is the common difference, 13 is the first term. Now, in order to work out the 21st term, that is the nth term, we are going to use the formula a into n minus 1 into d. So this will mean that we can be able to substitute the first term, 13 plus 21, which is the nth term, term number n, then we multiply to 1.2. That is going to give us what? If we work it out, we are going to get our answer as 37 kilometers. So this means that you must know how to use the arithmetic series formulas, that is nth term and also the sum of n terms, as we're going to see also how to find the sum of sum to infinity for geometric progression. So find the total distance she runs in the 21 days period. So in the 21-day period, in order to get the sum of all the total distance covered, we are going to find the sum of all the distances. And we are going to use the formula nth term. So A represent the first term. I needed to identify that. D represent the common difference, and n represent the number of terms. Now we can be able to move to the second part where you're going to use some formula, and that's going to be n over 2 into 2a n minus 1 into d, and then substituting all everything that we have there, we can be able to work it out. And in the process of putting this in our calculator, let's see what we are able to see. This is going to translate to 525 kilometers. Now, the second and the third terms of a geometric progression, first, second, and the third term of a geometric progression are x, x minus 3, x minus 5 respectively. Find the value of x. We know in order to find the common difference, we take the number in front divided by the number below. That is finding the common ratio. Finding the common ratio, you take the number in front of the sequence, divide the number behind it. So we're going to form an equation like that, which we are going to solve, and that will enable us know the value of x. Now, once we know the value of x by putting the like terms together and solving the quadratic equation, we can be able to go ahead. Yeah, this quadratic equation actually is going to cancel out, and then we are going to have our x equals to 9. Then substituting into the terms that we were given, we can be able to know the common ratio and the first term. So we know that x is 9 minus 3, that becomes 6 over 9. And if you can simplify, you are going to get actually 2 over 3 as the common ratio. So we are supposed to find the fourth term of the progression, fourth term. So fourth term of the progression, that is going to be a r n minus 1. And remember, this is now arithmetic progression. So the nth term is given by this formula. Substituting a is the first term, which is actually 9. A is our first term, which is 9. And the common ratio is 2 over 3 raised to power 4 minus 1, and that is going to translate to, working out this, we're going to get 8 over 3, all right, which we can be able to write as 2.67. Now, sum to infinity is another area that you need to remind yourself. So the formula for sum to infinity is this. So first term over 1 minus the common ratio, and this sequence must be converging for you to work out the sum to infinity. So otherwise, the formula to use for them to give you a question to do sum to infinity, they must give you a progression that is converging. So basically, what you need to know is how to use the formula and what comes where. And our final answer now becomes that. Right, moving to circle geometry, circles, and the geometry of circles. Let's see, what question are we expecting at that given point. We are told that a circle has a center at the point B, 5, 1, and the point A, -1, -2 lies on the circle. Find the equation of the circle. So the first thing that we're going to do here, we need to find the radius of the circle. And the radius of a circle is obtained by finding the magnitude between B and A. We try to find the magnitude AB. So we were given the center there, and then we have a point on the circle, which is actually A here. So radius is going to be like that. So this is this is how we find the radius. When you are given two coordinates, you take one coordinate of x minus the other one, square that. X, that is x1 minus, that is x2 minus x1 squared, y2 minus y1 squared. Then you find the square root in order to work out the magnitude. And if you simplify this, you are going to get this is actually 45, which is going to translate to 3 root 5. Now, since we know the center, we can be able to use the the standard equation formula of a circle and then substitute what we know. A and B are the coordinates of the center and R is the radius. So we are going to substitute the centers there because the value of x was 5. So it's x minus 5 squared plus y minus 1 squared equals to 3 root 5 squared. So if we can square on the other side, we end up having this equation and we can say equals to 45. All right, the next part here, we are told that point C is such that AC is the diameter of the circle. Point D has a coordinate 5, 16, and then show that DC is a tangent to the circle. Something that we need to remember for a tangent of a circle is that a diameter or the radius meet the tangent at 90 degrees. So if we know the structure, the strategy I'm going to use in order to work out this question, I'm going to work out the gradient of the tangent. No, I'll start with the gradient of the diameter, and then I'll find the coordinate where the tangent and the circle meet, and thereafter I'll find the gradient of the line DC, and check if I multiply the two gradients, can I get -1? Because if two lines are perpendicular, then gradient the product of their gradient will give us -1. So that's why I'm saying, in order to work out this question, I'll start by working out the gradient of AC, which is the diameter. I can even say CB. I can work out the gradient of CB or AC, and then I'll work out the coordinate where that line DC rests on the circle. Once I have that coordinate, then I'll use the coordinates of D in order to work out the gradient. Then once I have the two gradients, I multiply them to check if they are giving me -1. So if they are giving me -1, it will mean that now that's the tangent. So we have the general coordinate C, X, Y. You can see now we can be able to find the gradient of the diameter using A and B. Yeah, we can be able to find that. Gradient of AB will be the gradient of that diameter. So remember, gradient of a line is actually change in y over change in x. That's y2 minus y1 over x2 over x1. I can be able to substitute the values there so that I can be able to get my beautiful gradient as a half. Then I need to find the coordinates of x and y. I'll use the midpoint formula because I know if I use the midpoint formula, it will mean that remember, if I take midpoints x1 plus x2 over 2, y1, y2 over 2, right? Like that. So I'm going to use this knowledge in order to find what my x is and what my y is. And definitely, if I equate the x plus minus 1 over 2 equal to 5, I'll be able to find that value of x at that point like this. Similarly, I'll do the same. Let me just move this a little bit here so that I can have enough space. I'll do the same to y, and I'll get my value of y as 4. So the coordinate of point C is actually 11, 4. And then now I can be able to find the gradient of that line. You see there the gradient is -2. Things are shaping up. If you multiply m1 and m2, you get -1. Let's check. Yeah, a half times -2, you are going to getting -1. Then perfect. And since the coordinate C is on the circle and they are agreeing like that, I can now conclude and say that AC, DC are perpendicular, and since C is on the circle, then we can now say that that is a tangent. The diagram shows a circle there and a straight line, so intersecting at the point A and the point D on the axis, such that AD is perpendicular to the x-axis. So the point is, I want us to know how to find the coordinate when a circle intersects a straight line. At that point, you're going to substitute part of the equation of the straight line where you have y on the equation of a circle. So I'm going to say we were given y equals to 2x minus 1, and the equation of the circle equals to that. So substituting equation 1 into equation 2, and then we are going to form a quadratic equation which we are going to solve. Solving that quadratic equation now, you can see now this is a difference of 2 squares, x equals to 1 or -1. So at A, x must be positive, but B, x is going to be negative. So that's why we are getting two answers, x equals to 1 or x equals to -1. But A has to take the positive coordinate. All right. You can see our time is moving very fast. I believe we are going to hit, and we are going to manage to finish this tutorial on the required time, as we said, under 2 hours, going through all the topics that you know, all the topics that you need to know under 2 hours. Let's see whether we'll be able to manage that. All right. So substituting the value of x equals to 1 into the equation y equals to 2x minus 1, that enables us to know the value of y, so that we can be able to have the complete coordinate of the point A. As that. The next question that you must know how to do, and I'm pretty sure that a question can come from here, is this kind of trigonometric identities, trying to prove that the left hand side equals to the right hand side. Yeah. So, and the other question that you can be asked on this regard is to show or express the right hand side in a given form. So let us just focus on this. Show that sine theta over 1 minus sine theta over 1 plus sine theta equals to 2 times square theta. So this means we need to use the left hand side to show the right hand side. Yeah. So let us start from the left hand side. Try to see if you work it out, can you be able to arrive at the right hand side? Then my students told me we can use butterfly method. Yeah? So we are going to cross multiply like that. So this is going to be multiplied on this end, and this other part will be multiplied to this, and everything under multiplied together. So we are going to multiply these two terms together like that. So we shall expand the brackets in order to simplify and get the cleaner part of the equation, and then you can be able to see some parts are going to cancel out. This is going to be this part will cancel out, and also this and this will cancel out. We end up remaining with 2 sine squared theta, 2 sine squared theta over 1 minus sine squared theta. So having this, having this part, we remember that cos square theta plus sine square, or sine square theta plus cos square theta is equals to 1. Then we can be able to say cos square theta is 1 minus sine square theta. So we can be able to replace this part under this area here. So we can be able to have this in terms of cos square theta, and then you can see now this is going to reduce to 2 tan square theta, because sine theta over cos theta is tan theta. At the same time, sine square theta over cos square theta is going to be equal to tan square theta. So since we were having that too, that is what is going to reduce to that. Now, part B have shown above, then you are going to use that part to solve, hence solve. So meaning the left hand side can be replaced with 2 tan squared theta, and then we are going to equate that to 8. So that is what we are going to do. 2 tan squared theta equals to 8, divide by 2 both sides, and then we're going to find the square root both sides. And remember that square root of a number is either positive or negative. So since we are finding the value theta from 0 all the way to 180, and we're finding positive angles, we're going to say tan theta equals to positive 2. So we're going to check in the 4 quadrants where is tan is positive. That's where we're going to get that angle. So we shall find tan inverse of 2, which is going to be 63.4 degrees. Then I need to draw the 4 quadrants, and we shall say now all student trust Cambridge. And now, where do we have tan positive? In the first quadrant and in the third quadrant. So we are going to put 63.4 at that point, and then we are going to extend this down below here. And this point, because of symmetry, is going to be 63.4 at that point. But since we are finding positive angles, remember we are not having negative angle. We are not having negative on the range 0 to 8. That's what I mean by positive angles. So all the angles are going to be measured in anti-clockwise direction. So the first angle that we are going to have is the angle that is measured from the x-axis, and that is 63.4 degrees. That's the first angle. Then the second positive angle is the angle that is going to be measured from here all the way to this particular point. Remember now, from we are having, how are we going to have the whole of this angle from the x-axis going to be 180 plus 63.4. So we're going to get this angle here is going to be 243.4, and the other angle is going to be 63.4. But you can see now this one here is out of the range. This one is out of the range. We're not going to consider it. Then we're going to move now to the next bit. The next bit that we have tan negative, where we have tan negative, that is in which quadrant? That's going to be in the second quadrant and in the fourth quadrant. So that's going to be tan inverse of negative 2, and that's going to be negative 63.4. So meaning this angle is measured in the clockwise direction. If you draw that, it's going to be below the x-axis, like that. So since we are going to measure positive angles, no, we are trying to find where tan is negative. We are going to draw a straight line like that. So in the second quadrant, we're going to have another angle there. So we are going to say this is going to be this angle, all student trust Cambridge. Then the next angle we are going to find is the angle from the x-axis to that point, right? So this is going to be 180 minus, this is going to be 180, this angle here, 180 minus 63.4, and so that's going to be what? Let's just use our calculator and try to find that. 116.6. Yeah, so this also within the range. So the two angles that were required for this question is these two values that we have there. Now find the equation of the normal to the curve. The equation of the curve is given by this. Find the equation of the normal to the curve. So meaning that the first thing you are to do is to differentiate the function so that you get the y dx. And the way to differentiate this, remember square root can be changed to raised to power a half. So in order to differentiate this function, the power that you have here, you are going to bring it down in front here times the number that was 2 there, then decrease the power by 1, then times 3, and this 3 is from differentiating then inside differentiating what's inside the bracket. So the first thing to do is to use power rule. Just disregard what's in the bracket, reduce the power by take the power down, then reduce the power by 1, then multiply to the number in front of x. Just understand it that way. So dy dx is equal to this, so meaning that dy dx is going to reduce to 3 over root 3x plus 4 minus 1. Then we are supposed to find the equation of the normal at this point. At this point, x is 4. So if we substitute x4, we can be able to get the gradient of the tangent. And remember, the gradient of the normal times the gradient of the curve, it should give us -1, because a normal is at a right angle, is at 90 degrees, with the tangent. So that's why we're saying m1 times m2 is -1. So which means that if you know the gradient of the curve, you can be able to know the gradient of the tangent. So this is going the gradient of the normal rather, which is going to be -4 over 3. So equation of the normal can be obtained from here. We know that the equation of a straight line is y equals to mx plus c. So we're going to substitute. Where you have m, we shall place -4 over 3. And where we have x, we are going to substitute 4. And where we have y, we are going to substitute. And that enables us to find the value of c. As c is 28 over 3. So if we can be able to write the equation in the standard form, to be y equals to -4 over 3x plus 28 over 3. So that's what you are supposed to do in that bit. A line of the equation this, and a curve has and a curve equation y equals to cx squared plus 2x minus 3, where c is a constant. So the line is a tangent to the curve. So meaning that the gradient of this line is equal to the gradient of the curve at that point of intersection. Yeah. So which means that dy dx equals to 2. If you differentiate this function here, we are going to get 2cx plus 2 should be equal to the gradient of the line, which is actually 6. So if we equate the gradient of the gradient function and the gradient of the curve, which is 6, we're going to have this equation. This equation is going to be very important for us when we're working it out. So the next thing is to equate this equation and this one, in order to, because they are meeting at one point, and they are meeting at actually one point, so that will mean that the discriminant is equals to 0. When you have a tangent, it means the discriminant is equal to 0. So you are going to equate this and try to work out the discriminant, and the discriminant equated to 0, try to work out whatever equation that we are getting here. So you see, I find the discriminant of this, and the formula for discriminant is b squared minus 4ac, and then I can be able to form a quadratic equation in terms of c. Solving that, I'm getting c equals to 4, or c equals to -1. Then now, since I have c and I have x, I have c, I can be able to go to this equation, then I am able to find the value of x. So I'm going to say from cx equals to 2, x equals to 2 over c. When c is 4, my value of x is going to be half. Then from the value x, I can be able to get the value of y. So I'll go back to the original equation here. Since I have since I have x and I have the value of c, I can be able to find the value of y. So which will mean that the first coordinate for p is 1 over 2 minus 1, and the second one, when c is -1, x is going to be -2. Substituting for the value of y, I'm getting p to be -2, and then -11. Okay, now in question number 18, a point P is moving along a curve in such a way that the x coordinate of the point P is increasing at a constant rate, 2 units per minute. The equation of the curve is this. So find the rate at which y coordinate is increasing when x equals to 1. So meaning that from this part we know that it's increasing. So we have a positive value for the rate of change of x. So the x dt is going to be equal to 2. Then dt dx is going to be the reciprocal of that. Dx dt is 2, dt dx is going to be 1 over 2. Then we can now use this equation that we have here and then work out dy dx. Dy dx, differentiating this, we said whenever you are differentiating this, you are going to take the power down. So that will be a half. Write the bracket the way it is, reduce the power by 1 times 5. Yes. Then now, because x is 1, we're going to find dy dx where x equals to 1. Substitute, you are going to get 5 over 4. Then once you have that, you can write dy dx equals dy dt times dt dx. We know dy dx is 5 over 4. Dy dt, we don't know it. That's the one that we are looking for, because we are finding rate of what the rate at which y coordinate is increasing. So that's what we are trying to find. And the dt dx is 1 over 2. Then substituting, we are going to get our dy dt to be equal to 2.5 units. 2.5 units. Find the value of x when y coordinate is increasing at the rate, y coordinate is increasing at the rate 5 over 8. Increasing at the rate 5 over 8. So meaning we are going to take the gradient function dy dx, gradient function, equate it to 5 over 8, because dy dt is 5 over 8 times 1 over 2, because we were told the rate of change of x was constant, was not changing. So we retained it like that, and then we can be able now to work it out and find the value of x as shown there. Because if you multiply by them, if you simplify this, you are going to get 5x minus 1 raised to power negative 1 over 2 equals to 1 over 8. Squaring both sides, we are going to reduce the equation into this, and then we shall now simplify further and get the value of x to be 1 over 3. Rather, the value of x to be 13. The value of x to be 13. Right. Question number 19, the function is f is defined by this. Determine whether it's an increasing function or a decreasing function. Remember, a function is said to be increasing if the f of x, f prime of x is greater than 0. A function is said to be decreasing if f prime of x is less than 0. So if the function, the gradient function is fully positive, it's an increasing function. If it's fully negative, is a decreasing function. Let's see what's happening here. If you differentiate this, you are going to get this part, and you see now is going to be negative 3 over 3x plus 2 squared. So meaning the whole of this thing, since it's squared, at any given point, even if we have negative values of x, it's going to remain positive. Then since we have a negative sign here, then it means the entire of this part will always be negative because of this negative sign here. And since we were told that x is less than negative 1, then it means that 2x is going to always be a negative value. So meaning, therefore, since always this is negative and this term is always negative, then the function f inverse of x is less than 0, which means it's a decreasing function. And finally, number 20, we're supposed to find the coordinates of the minimum point of the curve. Y is this. We are going to differentiate and equate that gradient function to 0. Dy dx at the minimum point is equals to 0, right? So if you equate that, you are going to if you differentiate this, we're going to get 9 over 2x minus 12, and simplifying and equating to 0, we're going to get the value of x as 8 over 3. So since we are finding the minimum point, we need the y coordinate. So we are going to substitute this value back to the original equation, and then the minimum point is that. And this marks the end of this tutorial. If you have learned something new from Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. The equation of the curve is such that dy over dx equals to 1 over x plus 72 over x raised to power 4. The curve passes through the point 2, 8. Find the equation of the normal to the curve. So since this is the gradient function, we can be able to substitute the value of x be equal to 2 so that we can be able to know what's the gradient of this curve at the point where x is to 2. So once we know that, we can be able to go ahead and then substitute the value of x equals to 2, and that will give us the gradient of the curve. And since we are finding the equation of the normal, we need to know the gradient of the normal, because the gradient of the normal times the gradient of the tangent or the gradient of the curve, they give us -1. So we can be able to use that 11 over 2 in order to find the gradient of the normal, and the gradient of the normal is going to be -2 over 11. Then we can be able to use the point P so that we can be able to work out the equation of the normal. We're going to say y equals to mx plus c, substitute the values and the gradient that you have so that we can be able to get the value of c as 92 over 11, and we can now write the equation as y equals -2 over 11 x plus 92 over 11. Find the equation of the curve. Find the equation of the curve. First, of course, we are going to integrate the gradient function. Upon integrating that gradient function, we are going to rearrange it. Let's just write it like that, integrating every term, all the terms. Integrating dy dx becomes y. Integrating this part, you are going to get that, yeah. And then now we have c. To find c, we're going to use the point that was given. Let me move this. We're going to substitute this point there in order to find the value of c. Now substituting everything, simplifying carefully everything, the value of c actually becomes 10, and then we can now write the equation of the curve like that. Okay, so the next part is trigonometric transformation, and this is a very common question. Remember, we are going to draw now the midline for this wave, yeah, the line of equilibrium, right? But you see it's passing -2, but originally it's supposed to be passing at 0, 0, along the x-axis, but it's passing, yeah, right? So let me just return back that we can be able to go where we had stopped. All right, so the axis, you can see now at that given point, supposed to be it has moved, it did move from 0 all the way to -2. So it's like the function has been shifted down. This function was shifted down, was moved how many steps down? -2 steps down, huh? So in this particular question, you are supposed to state the value of p, and actually the value of p is the amplitude. P is the amplitude of the wave, the maximum displacement from the mean position, so this is going to give us the amplitude, and that's going to be 3, because if you actually look at from -2 to 1, how many units do you have? You have 3 units. So p is sine, the number or the variable behind the sign represents the amplitude of that wave. Then we are supposed to find the value of Q, and actually Q is a half. The reason why I've said Q is a half is because I can see a wave, actually a sine wave, has a period of 2 pi, meaning a full wave fits in 2 pi. But when you look at this wave that we have here, only a half of the wave fits in 2 pi. So we are going to say therefore that is half. Yeah, if you draw it like this, a full period is 2 pi for a sine wave, but the way this wave has been drawn, it means it has been transformed such that sine a half theta, so only a half of the wave is going to fit in 2 pi. So that's why I'm saying I'll take that as a half. The next bit is how many units has the graph been shifted up or down? It has been shifted 2 steps down, so that is negative. A gradient of the curve is given by dy dx equals to 6 into 3x minus 5 raised to power 3 minus k squared, where k is a constant. The curve has a stationary point at this. So we know at the stationary point, dy dx is actually equal to 0. At the stationary point, dy dx is 0. So meaning that we're going to take this part that we have here and then equate it to 0 so that we can be able to find the value of k, right? Okay, yeah, so what I did, I equated that gradient function to 0, and then I substituted where I have x, I substituted with 2 because we were given the stationary point that is at the point 2, negative 3.5. So doing that, I've gotten the value of k to be 3 over 2. Find the equation of the curve. To find the equation of the curve, you are going just to integrate the gradient function that you are given. And the most important thing to do here is to know how to integrate this kind of expression, 6 into 3x minus 5 raised to power 3. And this is what we say we are using chain rule. Yeah. So the first thing we said, say we are going to write this as integrate every term. So write the expression the way it was, 6 into 3x minus 5 raised to power 3 over, yes, then we're going to increase the power by 1, so that will be 3 plus 1. That 3 plus 1, you divide it through here, and then the 3 that we are having in front of x, you bring it down here. Then you are done now. Yeah. So if you are having 4 in front of x, you are to multiply at the denominator by 4. So I believe that is well understood. Then also integrating this, we're going to have what? We are going to have kx cubed over 3, then plus c. But remember, we know what the value of k is. We can be able to substitute it here, and then we can be able to put in, we have that, we can be able to substitute everything, and then we have our expression like that. So we can simplify it further and then remain with finding the value, remaining with finding the value of c. And to find the value of c, we're going to use that coordinate that was given there. We shall substitute into it in order to get the value of c. And working out, we are going to be surprised that our c is going to be 0, and we'll appreciate all that we have done. C is 0, then we can now say, okay, fine. If it's 0, we can be able to write the equation that way, and then we just leave it like that. We appreciate all that it takes to find the equation of a curve, right? The next part here, we are supposed to find d squared y dx squared. So this is the second differentiation, And usually when you do this, it's going when you are given, or you are supposed to find the squared y dx squared. Basically what's happening there, they are trying to drag you so that you can be able to explain all state what type of station, what's the nature of the stationary point. Remember, the nature of the stationary point can be a point of inflection, can be a minimum, or can be a maximum. When d squared y dx squared is greater than 0, that becomes a minimum point. If it's less than 0, it becomes a maximum point. But if it's equal to 0, it means that you need more information so that you can be able to analyze and know which point is that. But at this given point, let us just differentiate further that function that we were given again. Dy dx was given as shown there, 6 into 3x minus 5 raised to power 3, and then we are supposed again to differentiate, that is minus what, as 3, yeah, x, after finding the value of k, right? All right, so now differentiating this again. Now the process of differentiating this, these are the kind of question I'm just insisting you know how to differentiate and how to integrate. Now to differentiate this, you are going to write, you are going to take the power in front, the power 3, you need to bring it down. So you are going to say 3 times 6, you have brought the power down, then write whatever that is in bracket the way it is, but reduce the power by 1, then multiply again by the number 3 that is inside the bracket. The 3 that I'm talking about is the one that is inside the bracket, the one that I've multiplied on the first expression. Then simplifying this, we are going to have our expression looking beautiful and beautiful like that, right? Okay. The 3 that I've multiplied after 3 raised to 3x minus 5 raised to power 3 minus 1, the 3 that comes there is the 3 that is inside the bracket. After differentiating 3x, you can get 3x. All right. Don't know whether I need to emphasize that any further. So I'm going to finding dy dx, differentiating this, we are going to get this. Okay, now these things, the next part you are supposed to find the nature of the stationary point. Yeah, so because in the previous question I was almost again starting finding the nature, yet the question for the nature of the stationary point is down here. So we are going to substitute where to the gradient function that we have 54 into 3x minus 5 raised to power 2 minus 3x. We're going to substitute actually x equals to 2 so that we can be able to find what's the value of d squared y dx squared. So if you work it out, you're going to get is actually 48. Now you can see the most important thing is that we know that is greater than 0. So this is a minimum point. Another bit that you need also to know how to work out is revolution on both the y-axis and the revolution on the x-axis. So if we are revolving this curve on the x-axis, remember we are given the limit from 1 is to 2. Let me just try to draw the diagram so that you can see how it's the solid gonna look like. So we are going to revolve that curve around, and this is the kind of the shape that we are going to get. And in order to find the volume of a revolution, the formula to use is v equals to pi integral of y squared dx. That's the formula to use. So you're going to take the graph, the function that you are given, square it, and then find the integral of that. So we were given this as our equation, so we are going to substitute into what we have, and then we are going to square everything, and this from 0, the limit is from 1 to 2, find the volume of that shape, and then we say with respect to x. Then squaring this is going to reduce to this value, yeah. So which will mean that now we need to integrate this. Now, do you know how to integrate this? We have worked question to make you aware how to integrate this. So remember we said in order to integrate this, we're going to write the bracket the way it is and the power -3. Then we're going to plus 1. Then the power -3 plus 1, we divide it through everything and then times 3. And the 3 is the one that is in front of x. If in front of x you are having 10, you are to multiply the denominator by 3. So don't forget that. Okay. Okay, now the limit is from 1 is to 2. And then now you proceed with the substitution, correct substitution, and ensure that you are very keen in your algebra workings so that you don't mess on a question that you could have gotten right. Now substituting everything that we are having here, let me just include my pi at the top here so that I can be able to work it out, and our final answer is going to translate to what? Simplifying everything, our answer is translating to 5/32 pi as our final answer. Moving to improper integrals, integrating to infinity. Yeah, so in such kind of question, if you are having infinity there, you change it to a number that you know, to a different number. You can now say integrating from 1 to m, so that m is replacing the infinity part. We are going to replace it later once we have done the integration. Then we're going now to write the function that we were given there and integrating this. Remember, we have done question like this, -2. Then now when you integrate, you increase the power by 1, that's +1. Then you take that power -2 plus 1, you divide it through everything, then times 4 now. You see that? Now that's what you do. The limit is from 1 all the way to m. The limits are from 1 all the way to m. And then we're going now to substitute everything that we have so that we can be able to simplify and get our final answer. So this is going to translate to that, and yeah, we have this. So as m approaches infinity, it means the number that we are having here becomes smaller and smaller. It approaches 0, so it becomes smaller and smaller. So if you are increasing the denominator, the fraction becomes smaller and smaller. That's why we're saying as m approaches infinity, whatever we are having there becomes approaches 0. So we are going to replace 0 in the first part. Then we're going to say, let me just move some space, 0 plus 1/24, and the final answer in that case is going to be 1/24. All right, let's move to the next question. In the next question here, let's see what we are supposed. A point is moving along a curve y equals to f of x in such a way that it passes through the point A. Its y coordinate is decreasing at the rate of k. So if you are told that it's decreasing, so you are going to say the rate is -k unit per second, and its x coordinate is increasing at the rate of k unit per second, so it's going to be +k. Now in order to work out this, we're going to use dy dx. Remember, we know that dy dx, we can be able to work it out. We know the function that was given here, so we can be able to let's write the function the way it was, so that we are able to find dy dx, and differentiating that, we are going to get this reducing to this. So we are going to have negative 8 into 4x plus what? Plus 2 raised to negative 3, right? Then remember that dy dx, rate of connectedness, dy dx is the same as dy dt times dt dx. Because if you can cancel dt dt, you are going to remain with dy over dx. So if you are finding dy dx, you can join dy dt times dt dx. And dt dx is the reciprocal is the reciprocal of is actually the reciprocal of dx dt. Yeah, let's go ahead. Dy dt already we know it's actually negative k, because we are told the value of we were told that the y coordinates are decreasing at the rate of k units. So dy dt is negative k, and the x coordinates are increasing at the value of k units per second. So which means also the dx dt is k, but when you say dt dx, you are going to find the reciprocal. So we are going to say 1 over k. Yeah. So dx dt equals to k. So which means now dt dx is going to be 1 over k. That's why we're going to multiply here, because remember we had said dy dx equals to dy dt times dt dx. Since our dy dt is negative k and our dt dx is 1 over k, we can be able to multiply the two and cancel out and get that dy dx is negative 1. So we are going to take the gradient function that we had gotten dy dx, the gradient function here, we are going to equate it to negative 1. So we are going to take that part and equate it to negative 1. And we're going to get our equation simplifying to that. If we do some algebra, we can be able to say this, finding this cube root both sides, then we can be able to find our value of x as follows: x equals to 0. So if x is 0, we can be able to find the value of y from the original equation by substituting what we know, and then our value of y in that case is 1 over 4. Then since we know the value of x is 0 and we know the value of y is 1 over 4, we can say the coordinate is 0, 1 over 4, like that. A point P is moving, is moving, a point P is moving along a curve in such a way that the x coordinate of P is increasing at a constant rate of 2 units. The equation of the curve is that find the rate at which the y coordinate is increasing when x equals to 1. So what is the first thing that we're going to do here? Right? Okay, let me just see what are we remaining. We have some bit to complete. So we are told that x coordinate is increasing at a constant rate. So we can say dx dt is equals to 2, right? That's the first information we have. And since it's increasing, so it should be positive. Don't forget that. Then dy dt is going to be, right? Dy dt is going to be the gradient function of that. This is dy dt or dy dx. Now find the equation of the normal to the curve. The equation of the curve is given by this. Find the equation of the normal to the curve. So meaning that the first thing you are to do is to differentiate the function so that you get the y dx. And the way to differentiate this, remember square root can be changed to raised to power a half. So in order to differentiate this function, the power that you have here, you are going to bring it down in front here times the number that was 2 there. Then decrease the power by 1, then times 3, and this 3 is from differentiating then inside differentiating what's inside the bracket. So the first thing to do is to use power rule. Just disregard what's in the bracket, reduce the power by take the power down, then reduce the power by 1, then multiply to the number in front of x. Just understand it that way. So the y dx is equal to this, so meaning that the y dx is going to reduce to 3 over root 3x plus 4 minus 1. Then we are supposed to find the equation of the normal at this point. At this point, x is 4. So if we substitute x4, we can be able to get the gradient of the tangent. And remember, the gradient of the normal times the gradient of the curve, it should give us -1, because a normal is at a right angle, is at 90 degrees, with the tangent. So that's why we're saying m1 times m2 is -1. So which means that if you know the gradient of the curve, you can be able to know the gradient of the tangent. So this is going the gradient of the normal rather, which is going to be -4/3. So equation of the normal can be obtained from here. We know that the equation of a straight line is y equals to mx plus c. So we are going to substitute. Where you have m, we shall place -4/3. And where we have x, we are going to substitute 4. And where we have y, we are going to substitute. And that enables us to find the value of c. As c is 28/3. So if we can be able to write the equation in the standard form, to be y equals to -4/3x plus 28/3. So that's what you are supposed to do in that bit. A line of the equation this, and a curve has and a curve equation y equals to cx squared plus 2x minus 3, where c is a constant. So the line is a tangent to the curve. So meaning that the gradient of this line is equal to the gradient of the curve at that point of intersection. Yeah. So which means that dy dx equals to 2. If you differentiate this function here, we are going to get 2cx plus 2 should be equal to the gradient of the line, which is actually 6. So if we equate the gradient of the gradient function and the gradient of the curve, which is 6, we're going to have this equation. This equation is going to be very important for us when we're working it out. So the next thing is to equate this equation and this one, in order to, because they are meeting at one point, and they are meeting at actually one point, so that will mean that the discriminant is equals to 0. When you have a tangent, it means the discriminant is equal to 0. So you are going to equate this and try to work out the discriminant. And the discriminant, equate it to 0, try to work out whatever equation that we are getting here. So you see, I find the discriminant of this, and the formula for discriminant is b squared minus 4ac, and then I can be able to form a quadratic equation in terms of c. Solving that, I'm getting c equals to 4 or c equals to -1. Then now, since I have c and I have x, I have c, I can be able to go to this equation, then I am able to find the value of x. So I'm going to say from cx equals to 2, x equals to 2 over c. When c is 4, my value of x is going to be half. Then from the value x, I can be able to get the value of y. So I'll go back to the original equation here. Since I have x and I have the value of c, I can be able to find the value of y. So which will mean that the first coordinate for p is 1/2 minus 1, and the second one when c is negative 1, x is going to be negative 2. Substituting for the value of y, I'm getting e to be negative 2 and then negative 11. Okay, now in question number 18, a point P is moving along a curve in such a way that the x coordinate of the point P is increasing at a constant rate, 2 units per minute. The equation of the curve is this. So find the rate at which y coordinate is increasing when x equals to 1. So meaning that from this part we know that it's increasing. So we have a positive value for the rate of change of x. So the x dt is going to be equal to 2. Then dt dx is going to be the reciprocal of that. Dx dt is 2, dt dx is going to be 1 over 2. Then we can now use this equation that we have here and then work out dy dx. Dy dx, differentiating this, we said whenever you are differentiating this, you are going to take the power down. So that will be a half. Write the bracket the way it is, reduce the power by 1 times 5. Yes. Then now, because x is 1, we're going to find dy dx where x equals to 1. Substitute, you are going to get 5 over 4. Then once you have that, you can write dy dx equals dy dt times dt dx. We know dy dx is 5 over 4. Dy dt, we don't know it. That's the one that we are looking for, because we are finding rate of what the rate at which y coordinate is increasing. So that's what we are trying to find. And the x dt dx is 1 over 2. Then substituting, we are going to get our dy dt to be equal to 2.5 units. 2.5 units. Find the value of x when y coordinate is increasing at the rate, y coordinate is increasing at the rate 5 over 8. Increasing at the rate 5 over 8. So meaning we are going to take the gradient function dy dx, gradient function, equate it to 5 over 8, because dy dt is 5 over 8 times 1 over 2, because we were told the rate of change of x was constant, was not changing. So we retained it like that, and then we can be able now to work it out and find the value of x as shown there. Because if you multiply by the, if you simplify this, you are going to get 5x minus 1 raised to power negative 1 over 2 equals to 1 over 8. Squaring both sides, we are going to reduce the equation into this, and then we shall now simplify further and get the value of x to be 1 over 3. Rather, the value of x to be 13. The value of x to be 13. Right. Question number 19, the function is f is defined by this. Determine whether it's an increasing function or a decreasing function. Remember, a function is said to be increasing if the f of x, f prime of x is greater than 0. A function is said to be decreasing if f prime of x is less than 0. So if the function, the gradient function is fully positive, it's an increasing function. If it's fully negative, is a decreasing function. Let's see what's happening here. If you differentiate this, you are going to get this part, and you see now is going to be negative 3 over 3x plus 2 squared. So meaning the whole of this thing, since it's squared, at any given point, even if we have negative values of x, it's going to remain positive. Then since we have a negative sign here, then it means the entire of this part will always be negative because of this negative sign here. And since we were told that x is less than negative 1, then it means that 2x is going to always be a negative value. So meaning, therefore, since always this is negative and this term is always negative, then the function f inverse of x is less than 0, which means it's a decreasing function. And finally, number 20, we're supposed to find the coordinates of the minimum point of the curve. y is this. We are going to differentiate and equate that gradient function to 0. dy dx at the minimum point is equals to 0, right? So if you equate that, you are going to if you differentiate this, we're going to get 9 over 2x minus 12, and simplifying and equating to 0, we're going to get the value of x as 8 over 3. So since we are finding the minimum point, we need the y coordinate. So we are going to substitute this value back to the original equation, and then the minimum point is that. And this marks the end of this tutorial. If you have learned something new from Proflan YouTube channel, consider subscribing so that in time I'm going to upload further tutorials, you'll be notified. All right, now moving to the last bit of this tutorial. We're given two curves, the green one and also the white one here. You can see this is 18 minus 3 over 8 x raised to power 5 over 2. Why is that? Equals to 9 over 4x squared minus 12x plus 18. Now, you see now, in order to find the area under the graph, you'll take equation of area under the graph is integrating from a to b the limits of the function y with respect to x. So in order to find the area of the shaded region here, what you're going to do is that you are going to take the graph that is above and then subtract the graph that is below, so that you can be able to get the difference of the two graphs. You will take this graph, then subtract this graph. If then from there you integrate the difference, that will be easier. Or you can just work out this, work out the area under the graph, and also work out the area under the graph of this, then subtract the two areas. But it's better you take the graph above, subtract the graph below, then integrate them, get the answer direct like that. So if you subtract, you are going to get your graph reducing as negative 8 over 3 x raised to power 5 over 2 minus 9 over 4x squared plus 12x, and then you are integrating with respect to x. So the limit of integration is actually was given here from 0 all the way to 4. So those are the x coordinates, the x values. Then substituting that, we are going to get our answer as 240 over 7. I wish you the best for all that you've done, and I believe some of the concepts that we have dealt with in this particular video, they are going to appear in your exam. Good luck to all of you, and you guys remember to subscribe and share this channel to your friend, because further we are going to work on P3 tutorials, P2 tutorials. As you are proceed to year 13, still this channel is going to be of great help to you in future. See you in the next video.